Okay, so let's get into what we're going to use to design this stuff. What are our codes and standards and some reference books? Both wood and masonry, they know that not all structural engineering civil programs are able to teach those, even though they're both really commonly used in the field. So both groups have quite a few resources online. So if you go to we talked about the wood references. Similar, if you go to the American Masonry Society, or the Masonry Society is what it's called now, TMS, and check that out, you'll find some free materials as well as some handbooks that you can purchase. So for this class, I'm going to try to give you everything you need, but I'll go through these references and you may wish to purchase them, but I don't want, because we cover two sets of materials and there's so many different references for this, I don't want to force you to do that. I will give you what you need. But if you do plan on designing with it, it doesn't hurt to have either the Masonry handbook to help with design or the code. All right, so Masonry, TMS, Masonry Society. This used to be ACI TMS. ACI still works on this with them, but it's handled, the committee itself is handled through the Masonry Society. So 402/602. So 402 is the code, 602 is the specification. So this is 402, this part is 602 specification. What's the difference? So a code is like 318 building code. A specification in ACI concrete, that would actually be 301, which you may or may not have talked about in class. That is related to the specifications for construction and the materials that go into these structures. Okay, so this used to be ACI 530 was the committee, along with ASCE 5 and 6. Okay, so now this is gone. And if you want this document, these are TMS 402/602 is what you want. Okay, and the commentaries are in here as well. Okay, so TMS is the Masonry Society. The committee is a joint committee that's responsible for both these documents. It's affiliated with the American Concrete Institute as well as ASCE and Structural Engineering Institute. Okay, so all of these guys work together. It's specified out of the IBC International Building Code, just like 318 is. All right, so the code side covers design and construction. And here's all the stuff it includes, but essentially one interesting thing here, it also includes glass unit masonry. You've seen that 60s glass block, it's still used, and that actually has coverage in the design code, veneers, and AAC, autoclaved aerated concrete masonry. So this is an autoclave process, so high pressure and temperature, that makes a super lightweight block. So that's also covered. And then the rest is typical structural items similar to what we did for wood. There's a empirical design method for specific location and criteria that they have. We'll talk about that a little bit in here. The specification part, the 602 part, covers the construction requirements. And so an example would be the QA, quality assurance for the materials. How do you place, bond, and anchor the masonry? And then how do you place the grout and the reinforcement? So like I said, the equivalent in ACI is 301, ACI 318. So for buildings, this is the code in concrete, and this is the spec, the construction spec. Okay. So that's what we had for reinforced concrete. And what we have for masonry is a similar layout, but it's 402 and 602, and they're put together. This is available from the Masonry Institute of America. It's on your reference list in the syllabus. This is a handbook. It's essentially a really good type textbook, or if you've had pre-stressed concrete, this is like the PCI handbook, right? Lots of examples and information about masonry. Very handy. So it's the 8th edition of the handbook, talks about materials and properties, loads, We are not going to directly cover loads in class. We've done this in other classes and before. Lateral forces, this is also not just a masonry item. That's wind loads and things like that. We've covered in other classes. What we are interested in is allowable stress design of structural members. Okay, and it's all the usual suspects: flexure, shear, compression, combinations of that, anchorage, bearing. Beam specifically, column specifically, the biggest usage for most of us will be walls. We are not covering strength design. Sorry, that's my dog JJ, who's mad at me because it's dinner time for him. Apologize. Details of reinforcement. We're not going to get into a ton of detail work in here. I want you to have a grip on the basics, how to use this code, and how to design the walls. Okay, so that's what we're going to focus on. No special topics. This is a bunch of formulas that are handy to have. So this is the difference between a handbook and a code. And you may have noticed in the PCI handbook. So when you're used to using something like ACI 318, right, it's the legal language on the left, and on the right is some commentary that talks about where it came from. But general, like mechanics equations and other things like that, are not in the code, right? We don't have an example of how to use, how to design a beam and flexure in the code. We have the requirements, okay? And it says things like you're allowed to use the Whitney stress block, but it doesn't go through an example problem or even give you the formulas for a lot of those example problems. There are some formulas, the ones that are defined by code, okay? So in a handbook, it's set up more like a textbook where you've got the things you need to know. And in this case, they've put all the formulas together in chapter 10, but it's handy as a reference. Okay. And then at the end of this handbook is a one-story industrial building example. So if you want to buy something to have in your books from this class, this is a good one because it's got the examples. If you go work for a firm, they may have this, but they will have the code for you. Oops, sorry. All right. So chapter 12 is the next chapter in here. Another design example. We're not going to cover retaining walls, a common usage. This is more on the, it's a mixture between geotech and structures. And then in the last chapter, there's a ton of tables, or as Dr. Christian says, oodles and oodles. So we don't care about the strength design tables in this case, but we do care about some of these other tables that'll be helpful design aids. Okay. And of course, we'll go through examples so you can see where everything is. I think this is a little more straightforward than the wood design. The wood design is not hard, but between the use of the two different books that we have in there, you kind of have to know where things are, more so than usual. Okay, so before the 30s, it was basically unreinforced empirical. In other words, you design based on what we've always done before. After the California earthquake around that time, they realized that this just wasn't going to work in seismic regions, and you need steel in there to handle the tension as well as kind of the ductility requirements. UBC is what they used to call IBC/ICC. So this was the United Building Code. It's now the International Building Code. So in the 30s, there was a working stress procedure for masonry so that they could size these members with reinforcing. It's an engineered approach rather than an empirical or, kind of throw it together approach or based on what's always worked. And this has been used through most of the 1900s. It evolved over time. At one point, if they could inspect the masonry, ensure there was good quality control, you got a third bump in allowable stress. Fairly, in the last decade or so, I believe is when it happened, they increased this 1/3 stress. They got rid of that piece, but you got a higher allowable stress. And all the quality control pieces now wrapped into the spec part. All right, so regardless of the changes, it's got a lot of similarities to wood because it's using this allowable stress design. It assumes the traditional straight line elastic working stress. In other words, you're in the elastic region, so your stress strain curve is that, okay, until it's gone. That makes things a little bit easier because I can go from stress to strain very quickly, among other things. It assumes that the masonry resists compression only. That's similar to concrete, and that the steel resists the tension, right? So the same thing we had with concrete on concrete for compression, steel for tension. So we've got big C and big T, and that's going to be the masonry, and the tension is going to be the steel. If there's no steel, we're going to be designing with the reinforcement because there's not much to do with the unreinforced masonry. It just takes the dead load or the vertical load. Okay, load combinations. So you may want to mark this. No seismic loads in this particular group because we're not going to deal with that. These are the 7 cases, load cases or load combinations that we'll be looking at. Should look pretty familiar because these are the same as wood. They're the ASD, the same deal. Why is it the same? Because it comes from ASC 7, the load book. Okay. In your dead load of masonry, there's tables that can provide that. We'll go through that when we do an example, but we can assume, or we can talk about that when we do an example. What we're going to assume is 140 pounds per cubic feet. Okay, so normal weight concrete weight for the CMU, sorry, and for the grout weight. All right, so normal weight concrete, if reinforced concrete is 150. Okay, and we'll go through this in example too. Okay, I'm actually going to stop right here on the masonry or on the spec since it's a good kind of breaking spot before we get into the design.